Okay, so today's lesson is going to feel very similar to what we talked about earlier in chapter 3, okay? The only difference today is that we're going to actually be proving the lines parallel. And to do that, you remember last time in the very beginning of chapter 3, we said that if two lines were parallel and cut by a transversal, then those four things were true, which we'll talk about in a minute. So today, if we're going to prove that the lines are parallel, then we're going to start with the converse of the statements that we learned previously. So, if two lines are cut by a transversal, so the corresponding angles are congruent, then the lines have to be parallel. So this time they're telling you that the ones that are in the same spot, if they are congruent, then the lines must be parallel, okay? So that's the converse for the corresponding angles postulate, okay? The next postulate they talk about is the parallel postulate. Last time we talked about the perpendicular postulate, and the parallel postulate says if a line and a point not on the line, then there exists an exactly one line through that point P that is going to be parallel to the given line, okay? If I move on, again with the alternate exterior angles, consecutive interior angles, and alternate interior angles. Again, just like the corresponding, this is the converse of those statements, okay? So if these two angles are going to be congruent, these alternate exterior angles, okay, then lines P and Q have to be parallel to each other, okay? That is the converse of that statement. Remember, we use those two arrow marks to show that they're parallel, okay? If any consecutive interior angles happen to be supplementary, remember that they equal 180 degrees, then that proves that these two lines have to be parallel to each other, okay? And then last, alternate interior angles. Again, if alternate interior angles happen to be congruent, remember then your lines P and Q have to be parallel, okay? The perpendicular transversal converse says that in a plane, if two lines are perpendicular to the same line, then they are parallel to each other. So if these two lines both happen to be perpendicular to that same line, then they have to be parallel to each other, okay? All right, let's go ahead and move on and let's do an example. Okay, so this first one up here I want to look at real fast. Look at this one real fast. It says, given the following information, determine which lines are parallel. If so, state the postulate or theorem. So we've got three lines here, okay? A says, suppose angle 1 and angle 3 are going to be congruent, okay? If they are, their location here is that they are corresponding. They're in the same spot, okay? And since they are corresponding, they're telling you they're going to be congruent, then guess what? Those two lines are parallel that contain 1 and 3, okay? This would act as your transversal. So A is going to be parallel to B. Notice how I didn't even look at C because it didn't contain either one of those. Okay, the next one says, and B, says that angle 1 is 103, okay? And angle 4 is 100, okay? First of all, they're not congruent, okay? If I know, because I know 1 and 3 are going to be congruent, these two lines are parallel. If I say that, then 103 has got to be angle 3 as well. These two angles are alternate interior. These are not the same. So regardless if I said that the alternate interior angles, they would have to be congruent in order for these two lines to be parallel as well. So actually, these you could consider as no relationship, but if you use the relationship that you already know, these two would have to be alternate interior, and if they have to be alternate interior, then B and C is not going to be parallel, okay? So B and C is not parallel. A and C, these would actually be alternate interior as well if we didn't look at line B. And again, they are not congruent, so we know that A is not going to be parallel to C as well. All right? Okay, our last example for today, looking at example 2. And like I said, this is going to seem very similar to what we've done before. So it says, find the measure of angle Z N right here, this angle right here, so that lines P and Q and MN are parallel, and show your work. So in order to do this, we have to use one of our 4 ways that we said, okay? Alternate interior angle, alternate exterior, corresponding or consecutive interior, okay? At this moment, these are actually going to be alternate exterior angles, okay? And since they are alternate exterior angles, we have to show that they're congruent, all right? So we have 11x minus 25 is equal to 7x plus 35. Let me double check and make sure I wrote down the right numbers. Yeah, okay. All right, so then if I subtract 7x, I get 4x minus 25 is equal to 35. When I add 25, I get 4x is equal to 60, so x is equal to 15. All right, so it says find the measure of the angle. So I've set them equal to each other because they are congruent. That means that I've proved that these 2 lines are parallel, okay? But now I need to find the angle, so if I plug it in for the angle of ZYN, that's going to be equal to 7 times 15 plus 35, which is going to give us 140 degrees.